So Basil's a huge nerd, and we're starting chapter 4. I didn't have a good one for it. So, yeah. Oh, yeah. And volleyball is like super easy. Almost as easy as swimming. Just kidding. All right. Trigonometry. Me too. I'm pretty athletic without that. Like I have pretty good reflexes and like ability to move in a certain way, unless that certain way is a really long distance. Can't do that. What's trigonometry? What part of that would make you think it's triangles? Trigons. Now, if you've ever been lazy with stuff, and you guys all had me in geometry, what do you call a 5-sided polygon? A pentagon. What do you call a 7-sided polygon? So almost. The real word is a heptagon, hepta, but I don't call it a heptagon. I'm lazy. I call it a 7gon. Like, it works. You were close. It's dumb, but you could call a triangle a 3gon. Or if you would rather, the different word for 3 would be tri. So this is triangles, trigons. What is metry? Like, so you're close. If you were to have a meter, what are you going to, I don't even want to say the word. That's it. That's what it is. It's the measure. So when we look literally at trigonometry, it is the measure of triangles. That's it. Okay. Now, the good news for us is that you have been, what's the word here? When you're raised and, oh my gosh, it's just total tip of my tongue. When you're raised, indoctrinated, there we go. You have been indoctrinated your whole mathematical lives, unfortunately. And it's happened a few times that you might recall. When you were younger, do you guys know what indoctrination is? So my kid probably doesn't hold political beliefs. Does that seem reasonable to you? Because he's 4. He shouldn't hold political beliefs. Now, in a couple of years, if I speak about politics at home, might he hold political beliefs? And he might just be spouting whatever it is that I talk about at home without really knowing what it is. But he probably believes it because he's grown up hearing it. But he's not really put the thought into making it. He just has a belief that I have just implanted in him, right? Like I programmed him to have that belief. And whether I do it intentionally or not, it does happen. If I was super duper pro, I don't know, no school, probably not going to be, but maybe I hold the opinion that I hate school and it's dumb and I don't think anybody should go. He's going to agree with that, whether he really has given the thought to it or not, right? So he has a belief that maybe he hasn't formed or doesn't have a reason to believe, but he believes it. He has been indoctrinated in that situation. Now, you guys have been indoctrinated as well over and over the years. And I'm just going to give you a few examples of it. Up until Algebra 2, if I asked you to do the following, you probably would all give me the same answer. So not up until Algebra 2. Before you looked at this in Algebra 2, what were you told? Miss Jarvis lied to you over and over and over. Can't do that. Doesn't work. Doesn't exist. That's not true, right? But it does exist, and we just didn't give you the whole truth. Now, you have been like I wouldn't really call that indoctrination because ignorance of the existence of something, I don't know if that really counts or not. But you have been indoctrinated. What do we use to measure angles? Like, how do I measure an angle? Like, this is, did not say ankles. I would never talk about such a controversial topic. But so here's my hand. What am I holding it at? Roughly what? 45 degrees. Now, it's going to seem like a silly question. Do you guys know how degrees work and everything? Ooh, really? So what do you mean they're arbitrary? Who? You might remember me doing something like this at some points in geometry. Anybody remember what I'm doing right now? I'm counting, and I'm counting to 12 on one hand, and then I can count to 60, right? So 360 degrees is how much? A full circle. 360 degrees is a full circle. Now, there's no reason other than because we said it is, right? Like it just doesn't exist. If there are aliens, and I'm just going to say, if we'll just pretend there are, let's say there's an advanced race elsewhere in the galaxy, in our universe, that's probably, if they're advanced, they probably discovered math. Like, it probably looks different than ours. The ideas won't be different, and it's a weird concept because the same universe exists. So they're going to find the same things that we find. They might write their numbers differently. Like maybe what they found when you take a circumference of a circle and divide it by the diameter, maybe they called it, instead of pi that we call it, they might call it this, right? Like this could be how they write that number. And it's weird to think about, but they would still discover the same values. They would have pi. They would have E, 2.718. It would naturally show up because when they're trying to model stuff that changes continuously, that number shows up. They're going to have all the same mathematics, even though it might look different. Do you think the odds of them having agreed amongst themselves that 360 degrees is what we should use is going to happen? Probably not. Now, the cool thing is, I guess one partly cool and partly terrible is, do you think there's one that would be common? Radians would be common. There is a way to measure angles that no matter where you are in the universe, if you're an intelligent species such as ourselves, you would discover this idea if you're doing mathematics. So, right to start us off, in chapter 4, we're going to talk first 4.1, and we're just going to be looking at measuring angles. That's it. So since trigonometry is a study of triangles, and triangles have 3 angles in them, it makes sense that we would talk about how does one actually measure an angle. Okay, dig deep into our collective geometry. How do I shorthand angle? I don't like this. I add one more mark to it. I add the arc across it. Now, if for whatever reason you guys are sending emails and you're talking about how much you love thinking about these angles and stuff, I just want to show you. Alt, if you hold it on your calculator, sorry, computer, Alt, and on my number pad, I'm going to type 8737 while I'm holding down the Alt key. I'm going to let go, and there it is. Okay, there is a way to type it. Nobody's going to send a message with angle in it. Alt 8737, or that's the one that I use, but you might hold Alt down and hit 8736, and then you get this one. Why don't I use the second one? Anybody recall or think of a reason why I don't use this? It looks like a less than is the reason that I don't use it. Now, as we're going through that, don't really care if you know how to type it on the computer. That's not my focus. But let's talk about some of these angles. So, in general, let's just give ourselves a good definition. Do you guys all know what an angle is? Okay, what's an angle? The space? Okay, love it. We're going to clean that up a little bit, but I agree with you. As we're thinking about an angle, we'll just say it's the amount of rotation between two, and then this part, I'm not going to write all the possibilities. It could be lines, it could be segments, it could be rays, it could be any of those things. I'm just going to say lines right now, okay? Or segments. Let's use segments. The amount of rotation between 2 segments, and these are going to be called the sides of our angle. Sides that share a common vertex or endpoint. That share an endpoint. Okay, that's it. An angle is just how much rotation do we have to do. Now, as we think about these sides do have specific names. We're going to sketch a quick angle, and we're just going to make sure that we can all agree when we're talking about these things what they are. So I'm going to sketch 2 segments because that's what we wrote, and we're going to say, here's an angle. Now, with this angle, there's a couple different things. I know that I could, and you guys won't add to this, but I could go from here, and if I just stick one endpoint, I could rotate up to there, right? Notice I went from the bottom one to the top one. I could do that. Could I also go from the top one to the bottom one? Now, the amount of rotation is the same in that situation, but they're not the same angle, which is a weird idea. As we look at this, we'll get there. But first, what is this part of the angle called? Somebody said it quietly, but you were right. This is my vertex. That's it. Okay, which means these are my 2 sides, right? I have two segments, the sides of an angle, that share an endpoint and the amount of rotation between them. Okay, so while we're looking at these, every angle ever has a starting point or a side and an ending point. Now, this could switch between them, but let's hypothetically say we're starting on this one. This is where we're starting, and we're going to rotate up this way. And I wouldn't draw the yellow yet, not the arrow anyway, not this one. Okay, give me another word for the starting amount if we link it back to stuff that we just talked about. So principal, or instead of starting amount, we could use a different word, initial. When we see this, if we're rotating this way, now I'll add this. This is my initial side. The initial side of my angle is where I begin. And when you land at an airport, and this feels like out of nowhere, but I promise it connects back. When you land at an airport, you land obviously on the runway, and then you pull to your what? The gate, and the gate is located at a very specific terminal. Why do we call it a terminal? It's the end of the flight. It's the ending location. So we have an initial side, and then we have a terminal side. Yeah, but only because they ended their last flight there. Yes. There's a place where that example fails. Okay. Could I switch colors and have it go the other way? I don't want to, if you guys are okay with saying they could switch. Okay. So we have our initial side and terminal side. Now, if this is our situation, is this direction of rotation? You don't have to sketch all this, but the way that I'm going now, am I rotating in a positive or a negative direction? So that I heard both of them. Counterclockwise. So it's definitely counterclockwise. I agree with you. For those of you that say negative, why? Because the counter part of it? Okay. What class are we in right now? Good. And just help me out here. Again, you don't have to sketch all this. But if we were to just look at our coordinate plane, we have 4 quadrants. Where's the first one? There. Where's the second one? And the third one's here? And the fourth one is here. Does what I just drew connect it all to the angles? Yes. If we went from 1 to 2 to 3 to 4, we would go that direction, right? Okay, so we're going to make a couple comments. I agree that there's logic going either direction, or we're just going to make a couple statements. Turns out an angle, and I would use the shorthand if I were you, is positive if counterclockwise. Now, I don't want to have to write counterclockwise over and over and over, and it's going to keep happening. I know what I want to write, but I'm open to suggestions for shorthand. CCW, are you guys okay for being counterclockwise? Okay, anti-clockwise is also appropriate, and it works. I think Europe uses anti-clockwise rather than counterclockwise, but it's the same idea. Okay, so what do you think we're going to say if an angle is clockwise? Negative. So we're going to introduce this. We'll say else, and this is kind of like computer science stuff, it's negative. Now, have you guys ever seen this language else? Like, you've seen the word else for sure, but have you ever seen it used like this? So all this is saying, and this shows up really commonly in like coding and stuff. This statement is true, and if this statement's not the case, then the only other situation would be it's negative. So it's just going the other direction. Now, that is me trying to save some time, but what direction would we rotate if we wanted a negative angle? Clockwise. Yeah, clockwise would be negative. Now, one more additional comment. On the coordinate plane, if we were to graph our angles and use like points and stuff, where's the natural starting place in your head? So like, for example, I'm just going to sketch here, and I guess I can do it here. I'm just going to sketch an angle down here because I don't mind having the picture. Really lazy coordinate plane. There it is. I want to draw a positive angle on this coordinate plane. And I'll switch color so it's really clear to see. I would sketch it, yeah. On the coordinate plane, I want to sketch an angle here. And hypothetically, let's say it's a 45-degree angle. I could draw that anywhere I wanted, right? Where would be the most convenient vertex, though? So the origin's a natural vertex choice, right? Okay. So let's just say I'm going to stick my vertex right here. Now, where do you want me to start? Like, where's the most natural feeling place that we would start measuring this angle? Like the initial side, rather. Say it again. I heard X and I heard quadrant. So quadrant 1, here's something in quadrant 1. Does that feel like a natural place to start my angle? Okay, so if I draw an angle here, does that feel like a natural way to arrange it? What would you want me to do with it? Like, I want to pivot this a little bit. Do you want me to pivot clockwise or counterclockwise? Okay, so I'm just going to pivot one side of it. I'll just do it with, like, as I'm editing. If this is my initial side, it feels weird. You tell me when it's a natural choice. Just the positive x-axis? Okay, I agree with you. If we have this angle right here is what we call in standard position. So on coordinate plane, it is standard, or it's, if you will, I'm going to make that a vocab. It's standard for initial side. And where did we just put our initial side? To be what? Be more specific, because I didn't use the whole x-axis, did I? The positive x-axis. Okay, this is an angle in standard position. Positive x-axis. Now, there are a few other things that, if I'm going way too slow or way too fast, as always, please tell me. But a couple other things that we just need to make sure that we have. How many Greek letters do you guys know? So you know a few by name. Do you know what they all look like? Okay, so we will use only a few of these, but it's nice to have them somewhere to reference. So this first little section is going to be super kind of sporadic everywhere. We defined an angle. Cool. We're going to sneak in another little piece. Let's talk about some Greek letters. And these are used commonly for angles, and it's the reason that we're looking at these. And I'm not going to make you learn the whole Greek alphabet, although I think you should. I'm not going to make you learn it. But there's some really common Greek letters that we use. And predominantly, there's like 3 that we use over and over and over when we're talking about angles. Anybody remember what this one is? And I'm going to draw it. I'm going to do it 2 ways. I'm going to do it really formally, and I'm going to draw it the way that I actually write it. So the formal version of this is a circle and this. That's what it actually looks like. It's not what it looks like when I draw it. When I draw it, it looks like this. Anybody remember what that is? This letter. Theta. Theta. It's a lowercase theta. It's a theta. These are common. We're going to see theta all the time. Now, it works as just like a variable like x. It's just indicating if we see a theta, pretty good chance we're talking about something angle related. Okay, others. This one is fairly common. Looks kind of like an A, doesn't it? Alpha. It's a lowercase alpha. And this next one, you're going to be able to guess. It has a tail. This is beta. Okay, these are the 3 most common letters that we're going to use. And I'm just going to put a little comment here. Unknown angles. Okay, these are the most common. Now, there are a couple more Greek letters that we'll see throughout the course of this chapter, but these are the 3 most common. Cool with that. Okay, so last little piece here that I want us to work out, and then we're going to get into how we actually measure these things. So we got some Greek letters, and normally I just work straight down, but because each little section is so short, I'm just going to bounce around. If you want me to work straight up and down so it fits a little bit better, I can. But can you guys organize your notes okay if I don't do it exactly like you do? Okay. So we're still in measuring angles and stuff. We're talking about angles at least. And we're going to talk about what we'll define it first. Coterminal angles. And small subsections over and over in this first one. Okay. If 2 people are cooperating, are they doing pretty much the same thing? Like, do they have the same end in goal or the end in mind? Weird. They're working towards the same goal, right? Co typically means together. Okay. You cohabitate rather with your siblings, your family, because you all live in the same house. If I have a co-terminal angle, what do you think they're doing together? So maybe even more than that. They what's the other word? Terminal. They end at the same place. Now, if we look at this, I'm going to sketch an angle, and I'm going to ask you guys to estimate this angle for me, just by eye. You don't even have to measure it, but we're going to sketch an angle on the coordinate plane here. So it's not going to be perfect, but I want it in standard position, which means where's my initial side going to be? What do you mean on the bottom? Because maybe. More specifically. There it is. Okay. So we're going to start this angle on the positive, or I'm going to have one side as the positive x-axis. So I'm going to bold this a little bit. So here it is. Okay. Now, I'm not going to tell you anything else except this. I want you guys just first with, we haven't mentioned degrees at all, but I think you guys have probably worked with them for 10 years-ish. You've seen them, at least known of them. I want you to estimate that angle. Think it out for like 10 seconds, chat with your neighbors, see if you guys agree. I just want to hear what you guys come up with. Estimate it if you're just looking at it. Ow. Do you think we all agree? Okay. Do you guys think we all agree? Check it out. 1, 2, 3. -2. Oh, wait. Why didn't anybody else say anything? I didn't tell you what to say. Gosh dang it. What do you guys think it is on the count of 3? 1, 2, 3. Why was I saying negative? Coordinates. What do you mean? No, we're not at the unit circle yet. Don't worry. Or you shouldn't even worry. Even if we were at the unit circle, don't worry. You guys all remember the unit circle being terrible? Yeah. Okay, check it out. I'm going to show you guys. So I don't either, Dolan, but everybody else seemingly does. I want you guys to finish this for me. Okay, do you guys know how to count down? Okay, I want you to count down when I start. 3. You guys can do the unit circle. If you can do that, you're golden. Like, you're fine. The unit circle is so much easier than you think it is. It's so easy. Okay, check it out. When you guys told me 135, I agree with you. Like, just so you know, I don't disagree with it. But I assume that we all looked at this angle. So that's probably where you looked. That's how you got to 135. Now, just to get a little bit of practice with our letters, I'm going to say that this orange angle, let's say it's alpha. So that amount of rotation, and it happened to be in the positive or negative direction. That's positive. That's counterclockwise. That's what we call a positive angle. Is that the only way that I could start here and end here? No, that's not the only way it could be done. I could have, and I'll undo the blue one, but I could have started here and then ended with, like, instead of doing this, which is fine, what's my other option? That way, right? Now, in that situation, do I start at the same spot? Does my angle terminate or end at the same spot? They start and stop at the same place. They are coterminal. This angle is a very different angle, even though it represents the same location at the end. This is beta. Now, are there more coterminal angles? Are those the only 2 possible rotations that could start me at the positive x-axis and end me there? You think there's more? How could I possibly make more? Gosh, what if we just, and I don't want you to add this one, okay? Because it's going to get too ugly too fast. If I start here and I go here, do I still end at the same spot? Now, I'm going to draw this one. You guys don't. That angle looks like this. We start and stop at the same spot still, but I've just gone an extra circle, right? But if I could go 1 extra circle, could I go 2? Could I go 50 trillion? Could I go in 50 trillion the other direction also? There's infinitely many that start and stop at the same spot. They're all coterminal. There are infinitely many of them. As we look at this, we'll be dealing with, like, how do we get here? eventually. But for now, I'm okay with them just existing. For our definition, just in case we need it because we forget this because we get a long break coming up, coterminal angles, all that we have to say is a start and end at same, at, how would I word? Can I say same side? That doesn't sound like it makes sense though. Same location. There we go. Locations. So if you were just reading this, that statement wouldn't really make sense. But with the fact that we just talked about it and drew it, we're going to make sense of what it says. Because when I read this, it wants me to make it think that it starts here and ends here, but that's not what I'm saying. They both start and end at the same spot. Okay. All right. So this next one is odd, and we're just going to check here. Why do we use, so without the why part necessarily, let's jump into our next part. So we talked about angles and just how to talk about them. How do I write down an angle? Do we even need it yet? Nope, don't even need it yet. So we're cool with that. Let's talk about measuring these guys. So second main topic, we talked a little bit about angles. Let's go a little bit further. How do we measure angles? And like not physically, how do we do it? Because you could use a protractor, you could use the sun if you wanted to. That's actually how they knew the sun or the planet was round a long time ago, or a sphere at least. When we're measuring angles, you guys have been trained to do this completely arbitrary method. If I said an angle is 50, that doesn't mean anything. An angle is 50 degrees. So we'll just get that one first. And this is going to be our short section. We have a degree, or degrees. It's this symbol. Okay, it's like a superscript or an exponent looking thing, right? We all know how to write degrees. Okay, here's the issue that I have. What's 1 degree? So you're right, but be more specific. 1 degree, how would you explain if somebody said, okay, so we measure in degrees, that's fine. What's 1 degree? How would you explain that to somebody? Love it. Love it, love it, love it. And it seems so silly, like not that that's the answer, but that is like the actual answer. It's 1 degree is literally 1/360th of a circle. And I'm going to say of a rotation, with the understanding that if somebody were to rotate completely around, that's just a circle, right? Like they've gone like, and it's weird because I don't think anybody's thinking this, but check it out. You say if I go a circle, I get 360 degrees, right? Is this what you had in mind, that I just walked in a little circle? You're clearly thinking about me doing like a spin, right? So some amount of rotation. Okay. I don't really hate this, to be honest. Like I don't mind them. In fact, in geometry, we spend a lot of time working on some nice angles. On the unit circle, you'll spend quite a bit of time working with some nice angles. Do you remember the nice angles? 90 is a pretty nice one. 0. 45 is another one. 360 is okay. 45 I heard. Yeah, I'm just looking at quadrant 1 first, because you're right, it will be eventually. 60, there's one more. 30. 30, 45, and 60 are like the main ones, and then 90s and zeros and all the iterations of them. Okay, degrees, I'm fine with, if you guys are fine with it. I don't want to talk a whole lot about degrees. Okay, more interesting than degrees and much more meaningful is the idea of a radian. Now, you guys have all seen this. I don't recall, did we talk about radians in geometry? Does anybody remember? Very briefly, I assume. You guys all remember seeing radians last year in Algebra 2? Okay. Can you tell me what a radian is? I legitimately don't know. Like, I don't know. Can you tell me anything about radians? What do you guys remember about radians? So, well, something about square root of 2. So you're giving me how to convert between stuff, right? So can we all just agree? Probably not a whole lot right now. That seem reasonable? Okay. Now, radians. I'm not going to write it down necessarily, but it's the way the angle should be measured and how we should have done it all the time. I don't know why we don't teach kids this initially. The number pi, you guys know what it is, roughly. Nobody knows exactly what it is, right? Because irrational never stops. But we all know it's 3.14 roughly. Okay. Where does that number come from? If you take the circumference of any circle ever and you divide by its diameter, you get pi. Now, what that means, and we generalize this out, is we're going to use that idea out here. Okay, I'm going to spend a minute to sketch a perfect circle. All right, it only took me one try. Here's my perfect circle. Oh, it bugs me. Okay, I have a circle. Now, it's on the coordinate plane. I took off all the numbers, and it really doesn't matter what they are, but this point is 0, 0. Are we all agreed with that? So if I were to use this to help me think about angles in general, like I could draw I could draw my initial side out to here, and then I could just start spinning, and it would just trace out that whole circle, right? Like I can see that that would happen. Do you guys agree with that? Okay, so I'm going to draw my initial side real quick, and then we're not going to label it the initial side this time. We're going to label it something different. So let's say here it is, and here is my initial side. That's what is my initial side, and it happens to intersect here. Now, with what we know about circles, does this distance mean anything? Like, how would we talk about this distance now that we have a circle on our board? It's a radius. Can we all agree with that? Okay, I'm going to call this R. That is R for radius. I'm not going to write it down. Now, at this point, and I feel like we did almost the exact same thing in geometry, but if you guys don't remember, I totally get it. I'm going to have you guys, we're going to try it, and we'll see a GIF of the same thing happening because it's going to look nicer with the GIF. Could I conceivably take this radius and just think about it as going up like this? Now, I wouldn't draw this, but do you guys agree that that's like the same size? Now, if you don't, I just want to highlight that the grid that I copied from, this is exactly the same size because it's a square. So these are the same size. Okay, so I could fold my radius up like this. Now, if all of a sudden I pretend like this was a rope or something, I could bend it onto this. And what I would see happening is, I'm just going to eyeball it out, this same distance probably corresponds along some path on the circle to about there is my guess. If this were to fold down onto here, it would probably line up about with that squiggly area. Do you guys agree? Okay, so I'm not going to undo everything, but I am going to erase this one. Oh, it's even getting worse there. Okay, I'm going to make a comment. With this, we have just drawn off a little tiny part of our circle, right? Now, do you recall from geometry what we call just that little section of a circle? Starts with an A. This is an arc of length. And how did we work out that length? We just eyeballed it here. Why did I make it this long along? Yeah, the length equals the radius. Okay, so again, just to reiterate, take an arc along this circle that goes the same distance as the radius would be. Now it just happens to be curved. Can I now form an angle? And it's this. Okay, now if we're looking at this, I'm going to say here's our angle that we just formed, and we're going to start using our Greek letters. Theta, not theta, like people call it the Greek cheese pretty regularly. Theta with a TH. Here's an angle theta. Okay, now there's some awesome things that happen with this. What we have just drawn on the board is 1 radian. Now, I don't have any idea what 1 radian is as far as degrees go. I've not a clue because I don't know. I've just never thought the calculation or did it. I'm sure I've done it and I just don't recall. But this feels random, right? Feels kind of random, I think. But here's the thing. If I let this go again, and we'll look at a GIF of this, when you guys are just going to help me estimate here, don't draw on yours, okay? Any of these new colors. You tell me when I've gone another arc length that's about the same as a radius. Where do you think I would stop? Probably about there, right? Okay, and we're just eyeballing right now. I want one more. You tell me when I go the length of the same arc. About there. How many radians did I get to right here? 1, 2, 3. And there's a little bit more than 3, right? Well, if only there was any special number that we knew showed up that was close to 3. Pi. And I'll tell you, it is exactly pi. When we look at this, This is pi radians to get to this half point on the circle. And there's all sorts of connections. 360 is arbitrary. If you got to pick the nicest circle that could ever exist, what would you want its radius to be? Easiest thing to think about. Probably not going to be 12, I don't think. We all agree that 1 would be more convenient. And seemingly unrelated, if we all work with the assumption that, hey, normally 1 would be perfect, could you find me the length of the whole arc? Like, when I say the whole arc, that's a weird way to word it. I'm talking about the circumference. How do you find the circumference of a circle? 2 pi r. Pi r squared is area, but I like that your head's there. 2 pi r is how we get the circumference. If the radius was 1, what would the whole distance around be? 2 pi times 1 is just 2 pi. Do you think other intelligent species, knowing that pi comes from this, they would probably find a formula for circumference, right? So if I said I went pi around the circle, if 2 pi is the whole circle, how much is pi of it? Half. And now we have another way to envision that, yep, it does wind up being half. I can see pretty close by estimating that it's 3 and a little bit, but I can also argue that if the radius is 1, this is just pi of 2 pi totals, right? Okay, I see this 2 different ways, and we now have this wonderful idea of radian. Now, I don't care if you have these other squiggly parts, but we're going to write a few things about radians, and then I think we're going to stop here once we do a couple little things with it. Okay, so as we're looking at these, some statements about radians that make them weird. Degrees is a unit. If you weren't aware of it, it's just a unit. Like, we actually have to say degrees. Radians are unitless. And it makes sense to why they would be unitless here in a second, are unitless. Now, there's a little bit of caveat with this because that bugs people a lot of the time. But if we think about how this works out, and we'll see that here in a second, there's no unit on it. With that said, if you want to write radians or rads so that you don't forget what you're dealing with, as long as it doesn't work its way into your final answer, I'm cool with it. Okay, radians are unitless. Now, by default, S is the typical symbol that we use for arc length of a circle. S is commonly arc length. Now, it's just the distance that we've traveled along the circle, a small portion of the circumference. All right. Now, as we're looking at this picture, it turns out that if we wanted to know how far that we've actually traveled in radians, that theta number, all that we have to do is say, well, theta, whatever angle, and it's seemingly this angle, if we wanted to actually find what it was, we know that this theta right here is how many radians? That's 1, that yellow region. And I'll just, if it's not clear yet, this whole thing, and I don't know the right way to do this, this is 1 radian. Well, how would you get 1 as a measurement out of any of these lengths? What would we have to take to get 1 out of it? Like, I could try doing theta over r, but maybe it's 1, right? Like, that's a weird idea. But is my arc length S and this the same distance? Like, they have to be, because that's how we formed it, right? So I think that it's reasonable, and you guys will probably believe me, that right now as I write theta, which is 1 radian, I think we could probably just take the arc length S and divide it by the radius. Now, this goes back to that 2 pi idea, and I know we're coming at this a couple different ways, but one of them is going to click. Like, we're seeing it just 2 different ways at the same time. If I wanted this to be a full circle, then the whole arc, the whole circumference would be 2 pi r over r, and we get the whole circle as how many radians? And I'll write that out because that's a lot to think about. So here we have this idea. S is commonly arc length, and from that we get theta is equal to S over r. Now, if I wanted to know what is theta for a whole circle, for example, for a full circle, if we use this formula, let's just reason out a different way. If I wanted the whole circle, you guys already know that it's 360 degrees, but I don't care about degrees right now. If I wanted to rotate a whole way through, what would the length of the arc that starts here and goes all the way through be? It's a circumference. And remind me, how do you find the circumference of a circle? So I would say the arc length is just 2 pi r. And we would divide it by, how do we write radius? Because that's all we said here. R. And what happens? So all of a sudden, we can see that rather than just me telling you, like, check it out. How many radians are in a full circle? 2 pi. And every intelligent species that ever discovers pi will discover this same measurement. There's no chance that they're going to do 360, but they're going to find 2 pi. So if we have this, we don't care about how big the circle is. I can just tell you, if I want pi radians, how much of a circle is it? So if this whole thing is 2 pi, how much is pi? Half of it. What about pi? What's half of pi? It just starts here and goes here, right? So pi halves is this angle now. Could I cut it in half again to get pi fourths? For sure. We can move between here without knowing degrees. We can just work it out. Now, you might recognize some of those values from the unit circle. I assure you, we are not doing the unit circle yet. But they do show up here just as we start talking about it. Naturally, they show up. So, good. Dollars, one might hope. Okay. Said it makes sense. All right. So, last little thing, and this is where we're ending. Some convenient values. Some convenient values. I love trig, by the way, and I hope you guys will. You might not yet. I don't know if you'll love it as much as I do, but you won't have a disdain for it. Okay, you might have a disdain for it, but I'll still love it, and that's what really matters. Some convenient values. Okay, 2 pi is how much of a circle? So, like the idea, Red, hate the language. It's a full circle. You are correct, though. It is the same as 360 degrees, which means let's do some reasoning. I want you guys to fill in the blanks here. You don't have to write is a. I used to do this all the time, but I quit doing it when I had a bunch of repeats. I would just do quotations to say, look, it's the same thing, but I don't like the way it looks. And back then, I couldn't do this either. So I want you guys to do this thing. 2 pi is a full circle. Well, what about a half circle? And then the thing that I was talking about is I couldn't do this before I started doing it. I want you guys to answer a couple of these random ones. And some of the A values won't make sense, but I want you to tell me how many radians is a half circle or a quarter circle. And this last one's going to be weird, but I promise there's a reason that we're doing it. 1/6 circle. Cool. I want you guys to answer these ones for me, and we are at a natural place to leave off here for. Yeah, we're at a natural place to stop here. Give me these blanks, check them with me. There is no additional homework tonight. Here's the deal. I can't give you guys 5 days of nothing, and I won't. But what I can do is, since we're starting new stuff and we're going to have to split it, is I'll promise you right here, right now, I will not give you homework to do outside of class before the end of the semester again. Cool. Awesome. So get those blanks filled in. We'll pick up here tomorrow and chat with your neighbors. If you're having trouble with it and you don't understand something from today, now would be a fantastic place to ask about it, because the weather is beautiful outside. My back is not hurting near as bad, and I'm in a good mood.